Welcome everybody. Now here we are going to see the general expression for the velocity of the wave in a gaseous medium whose density is rho and bulk modulus is of that elasticity is taken to be E. So here when we want to find the general expression for the velocity of a wave, so let us see what is being required for that. Now if you look here, you will find that velocity of the wave in elastic media is taken as V is equal to under root E by P. Now here E by P, E is called as the elasticity and rho is called as the density of the medium. So it is very innocently given by Newton, and Newton assumed that the sound wave travels in an condition known as isothermal condition. Isothermal condition means what? It is a condition where the temperature remains constant. So hence we say that it is isothermal. Therefore, we write this E term, that is elasticity term, as isothermal, because in isothermal condition the elasticity property does not change. So we write this equation V is equal to under root E isothermal upon rho. Now in isothermal process, if we focus for the isothermal process, we come to know that PV is constant, pressure into volume is constant, and if we differentiate this equation PV is equal to constant, we get one time P is constant, one time V is variable, so P dV, and in the next term when we consider V as constant, P is taken as variable, so we get an equation P dV plus VdP is equal to 0. Rearranging the terms, we get dP upon dV is into V is equal to minus P. So here we have got the value that dP upon dV into V is equal to minus P. Now volume elasticity. Now volume elasticity tells us what? That this term, now this is the volume elasticity, E is equal to minus V dP by dV, because we know that E depends on the volume. So hence E isothermal is equal to P. E isothermal is equal to P. And next, at NTP, then the density of air is given to be 1.293 kg per meter cube. Hence, V is equal to 1.01 into 10 raised to 5 upon 1.293. So, if we calculate it, we get the answer to be as 280 meter per second regarding the velocity of the sound in air. This value, if we compare it with the experimental value of sound, velocity of sound, theoretical area was 332, but when we calculated it, we have got 280. It says that it is 16% less than the experimental value. So this is all about the equation. Now we are going to see the new point that is called as the principle of superposition of wave. Now here, principle of superposition of waves. When two waves comes together, what will happen? Now we know that these are the vector quantities, because displacement is nothing but what? It is having some value, that is magnitude and direction. So now here we are taking the example of two or more waves. For understanding purpose, we take two waves. It is traveling through the medium, and they are arriving at a point of medium simultaneously, just like a Example I would like to give is about the railway platform. Now, you know that at the platform of the railway station there are 2 to 3 tracks, 2 to 3 or 4 number of platform depending upon the junction, railway junction. So for the understanding purpose we consider only 2 tracks. One is coming and 2 tracks. The trains are coming, they may be coming in the opposite direction, and when they are coming they are going to be halted for a few minutes at your platform, and then whatever the scene which is being created when these 2 trains comes together at the point of medium, that is at the point of platform, it says that first of all each wave means each railway produces its own displacement, means it is producing its own displacement. Suppose it is coming from Pune to Ahmednagar, so it is 120 kilometers, it is its own displacement. But this 120 kilometer is independent of the other. Means suppose one is coming from Manmad to Ahmednagar and one is coming from Pune to Ahmednagar, and if I take the displacement means the distance whatever it is being produced from Pune to Ahmednagar, that if I take 120 kilometer and suppose I take 150 kilometers from Ahmednagar to Manmad, what happens? Taking into consideration this explanation, we say that each wave produces its own displacement, that is one will produce 120 kilometers, other will consume 150 kilometers. So this 120 and kilometer and 150 kilometers, they are independent of the others, means they are independent of each other. So hence, if we take the resultant displacement at that point, it is equal to the vector sum of the displacement due to all the waves. So here in this situation, if you look, you will find that now we are going to take the resultant of these 2. One is coming from Pune, one is coming from Manmad, and if I calculate it, total displacement, then it is the vector sum of the 2 displacement, 120 plus 150, it will be 270 kilometers. So this is due to the reason of superposition of wave. When they come together, meet at a point Ahmednagar, those 2 railways I am speaking about. But when I speak only in terms of waves, I consider that 2 or more waves are coming together, or they are traveling through a medium, and they are arriving at a point, that point of medium simultaneously. Then we have to take individual consideration, that is each wave produces its own displacement at that point, independent of the other. So hence the resultant displacement at that point is equal to the vector sum of the displacement due to all the waves. Wait here.